Okay, hey, Colfax Math here. We're going to go over trig identities, either for pre-calculus class, trigonometry class, and you might even see these in some Algebra 2 classes. So the first 6 identities is sine is the reciprocal of cosecant. So sine is equal to 1 over cosecant, or cosecant is equal to 1 over sine. Sine cosecant multiplied together equals 1. And that's also true for cosine and secant. And then tan and cotan are reciprocals. These two I could remember because they make sense. For sine and cosecant, I remember C and S go together. So cosecant and sine, cosine and secant are reciprocals. Remember that all this is based on the unit circle. Any point on that unit circle would be a point xy. I go over x units, up y units. I drop in my vertical, create my right triangle. This leg right here would be my adjacent, or x. This leg right here is my opposite y. It's a unit circle because the radius is 1. If this is my angle of rotation, theta, cosine of theta is equal to adjacent x over hypotenuse 1. So x and cosine of theta are the same thing. And I could do the same thing for sine of theta. Sine of theta is equal to opposite over hypotenuse, or y and sine of theta are the same. So I could replace x with cosine, and I could replace y with sine. And I could figure out a lot of my other identities off of that. So I guess the first identity there is tangent. Tangent is equal to opposite over adjacent. So opposite would be sine over adjacent cosine. And this is my quotient identity, and there are 2 of those. Cotan is equal to adjacent over opposite, or the reciprocal of tan, and I get cosine over sine. So these first 6 identities are your reciprocal identities. The next 2 are your quotient identities, and then the next 3 are your Pythagorean identities. Still working off of this, I have a squared plus b squared equals c squared, or cosine squared plus sine squared equals 1 squared. I could divide both sides of the equation by cosine squared. Let me get a pencil. If I divide both sides of the equation by cosine squared, I have cosine squared over cosine squared, which is 1. Sine squared over cosine squared, that would be tan times tan, or tan squared. 1 over cosine, 1 over sine. 1 over cosine is secant squared. I could divide through now by sine squared. If I divide through by sine squared, that gives me cosine squared over sine squared. That's that right there, times cotan, or cotan squared. Sine squared over sine squared is 1. 1 over sine. 1 over sine is right here. Divide both sides by sine, and I get cosecant times cosecant. So those are my 3 Pythagorean identities. And you should be able to write all 11 of these identities down. Not through memorization, really just through derivation. And then I would have these next to you when you do these identities. So the first identity I'm going to do here is number 7. It is tangent of x, or a, or theta, doesn't matter what, plus cotan of x, or a. And I'm converting that to cosecant times secant. So the couple of rules I try and follow is put everything in the building blocks of cosine and sine. Also, I only pick one side of the equation to work on, and then I work to simplify it to equal the other side. So I always start with the more complicated side, and then I work to simplify. And then I'm really it's a great review of algebra skills. So look what you could do with your algebra skills to combine terms or whatever you need to do. So on this one right here, because this is addition compared to multiplication, it's much more complicated. The way I add or subtract fractions is with a common denominator. And remember that every one of these is a fraction. So I'm going to put it in the building blocks of sine and cosine. So tangent is sine, cosine. Cotan is cosine, sine. And I'm proving it's equal to that. These terms right here are being multiplied together. So to add these together, I need a common denominator. You know, if this is a 2 and this is a 3, I would multiply this by 2 over 2. So the way I get a common denominator here is I multiply this by that denominator. I could only multiply by 1 so as not to affect the value. So sine over sine is 1. Over here, I multiply by cosine over cosine. Also multiplying by 1 so as not to affect the value. And then I have in my numerator here sine squared over sine cosine plus cosine times cosine, cosine squared over sine cosine. I have a common denominator now. I have sine squared plus cosine squared over that common denominator, sine cosine. And then any square is usually a Pythagorean identity. I go up here. There it is right there. Sine squared plus cosine squared is equal to 1 over sine cosine. But here I have two separate terms. Cosecant, 1 over sine. Secant, 1 over cosine. So that's what I have here. So I split this 1 over sine into cosecant. 1 over cosine into secant. And my last step is cosecant secant equals cosecant secant. Okay, let me do another one. Do number 11 here. So I'm going to keep this kind of as a reference. So I have it next to me. And then let me do, on the handout, let me do number 13. So number 13 is 1 plus sine of beta times 1 minus sine of beta. And I'm going to prove that's equal to cosine squared of beta. So I'm just going to write out the terms, not the x's or the thetas. Left side is much more complicated. I actually noticed this is a conjugate. Conjugate is something I multiply by to get a perfect square. Two quantities multiplied together, I FOIL it out. Algebra skills. First, outer, inner, last. So I have 1 times 1 plus sine minus sine. They cancel. And then my last term is minus sine squared. And I got to prove that's equal to cosine squared. Over here, and I see that if I were to subtract sine squared from both sides, I would have cosine squared equals 1 minus sine squared. So 1 minus sine squared is cosine squared. Through the Pythagorean identity, cosine squared equals cosine squared. All right, I better get to class. Good. All right, let's knock out just a couple more really quickly here. I'm going to jump down to 19. Again, it's really good to have these 11 in front of you to refer to. On number 19 here, I got cosecant squared minus 1 over cosine. Anytime I see a square, I think Pythagorean. So I look at my Pythagorean identities here, and here's cosecant squared. If I were to subtract 1 from both sides, I would have cosecant squared minus 1 is equal to cotan squared. So this thing right here is equal to a cotan squared. So this is equal to cotan squared over cosine. I have two terms over here, but they're multiplied, not addition subtraction. So that's why I picked this side, much more complicated with addition subtraction. So cotan squared is cotan times cotan. So let me do that. So I have cotan times cotan all over cosine. And then I have cotan here is cosine over sine. There's that cotan. this cotan right here is cosine over sine. And then I still have one. This cosine right here is in the denominator, so it's that cosine right there. Look over here, I want a cotan. Actually, I already have a cotan, right? I want a cotan. Here's a cotan here. So cosine over sine is cotan. And then right here, I want a cosecant, and a cosecant is 1 over sine. Well, that will cancel with that, leaving me with 1 over sine, which is cosecant. So cotan cosecant is equal to cotan cosecant. Okay, I'm going to do one more problem, and that should wrap it up. This problem right here is fractions being added or subtracted, clearly more complex on the left side. I want to combine all these things to equal a cotan. I know cotan is cosine over sine, so that's where I'm going to. I don't really see the solution yet, but I do see fractions, so I want a common denominator to combine them. I'll multiply this by sine over sine, multiply by 1, so as not to affect the value. I'll multiply this by cosine over cosine. Won't change the value, but now I have a common denominator of cosine sine, cosine sine. So in the numerator, I have cosine secant, right? Cosine secant, cosine sequence equal to 1. So this is 1 minus sine times sine, so minus sine squared of x. You should always keep whatever variable is in there. I get a little lazy and I forget to do that, but it's sine squared of x over that common denominator of cosine of x, sine of x. Doesn't look that much simpler, except for I do see a square now, so I know a square is a Pythagorean identity. If I subtract sine squared from both sides here, that and that'll cancel, and it'll leave me with cosine squared equals 1 minus sine squared. So this thing right here, 1 minus sine squared through the Pythagorean identity is equal to cosine squared of x, all over that common denominator, cosine x, sine x. Now it's actually looking a little simpler. Cosine squared of x is cosine times cosine. So cosine squared is cosine of x times cosine of x, all over cosine of x, sine of x. Everything's being multiplied together, so I could just cancel away. Those cosines cancel. I'm going to cotan, right? I'm going to cotan. Cosine over sine is cotan, so cotan of x is equal to cotan of x. QED, quite easily done. That's kind of old school geometry proof. It's Latin for quo epsilon demonstratum. What I was asked to demonstrate has been proven in that proof. All right, there it is. Trig identities, they take work. There's no way around it. You got to just kind of grind your way through them to get them done, but they are great. People love them so much in the math world because they really demonstrate logical thinking and a fundamental understanding of math, from fraction manipulation to algebraic manipulation. It's really a great test of really beginning math, algebra 1, algebra 2, and geometry and trig. So they're really useful in calculus. They're kind of essential. The more you do them, the better you get at them, but they're work. Okay, thank you for watching.